So, class, welcome to the second video of the lecture number 15. So, in this lecture, the first topic that will be discussed will be the interconnection of power stations. Power stations. Interconnection of power stations. You know that if you'll talk about all the generators or all the power stations or power houses in J&K, they are connected to northern grid. Okay, means 8 states of the northern India, they constitute one grid that is called as the northern grid. Okay, so all these stations are interconnected. So what do you mean by the interconnection of power station? It is nothing but by interconnection of power station we mean connecting two power stations or grids via transmission line. It simply means connecting two power stations or grids via transmission line or tie line. Okay, so this is known as the interconnected grid system. Okay, so interconnection of grid involves extra cost because for interconnecting two grids you need a transmission line, okay, to connect two grids. So means it will incur means involve, I will say it will involve more cost, more or extra cost, but still we are interconnecting means power stations, okay, at the cost of this means more investment. Okay, so why are we means interconnecting these power stations? Because there are certain benefits, okay, certain significant benefits of interconnecting, okay, power stations. It has certain significant benefits. So what are the benefits? So let us discuss one by one. First is reduced plant reserve capacity. Reduced plant reserve capacity. I'm not going to write on these, explain these, what are these things, but means I will not write it on, but I will explain. Okay, so what do you mean by reduced plant reserve capacity? Look, what we do by interconnecting the generating stations or power stations, what happens? The amount of reserve plant capacity as a whole is reduced. Okay, so if the means I'm saying reserve capacity is reduced. I'm not saying it is going equal to 0, but it is reduced. Reserve capacity is reduced. So if the reserve capacity reduces, what happens? The load factor will improve. If the load factor will improve, the efficiency of the operation, it will be improved. So I'm saying by interconnecting the power station, what will happen to the reserve capacity of the plant? It will reduce, and thus the load factor and efficiency of operation are improved. How load factor improves? Okay, because reserve capacity means our I told you what is spinning reserve. Okay, that is called as a reserve capacity. So means now when this reserve, by interconnecting the power stations, we are reducing the this reserve capacity get reduced. So means we can load the plant to its rated capacity. Okay, so this improves the load factor, and also the efficiency of the operation are improved. Number two, suppose we have one power station and there is some fault in that power station. Okay, so the load that is connected to that power station means what will happen to it? Will get affected. Okay, will not that load will not receive power. So what happens if the two means power stations are interconnected? In case of means any problem or any fault in one power station, still some part of the load can be, some part of the load, I'm not saying all the load will be supplied, means power will be supplied to the whole load from the another power station, but some critical load that can be maintained. Some critical load means I will say that means hospital load, certain critical industrial load, defense load, means we can supply power to that this critical load from another power station. For example, I am saying this is one power station. I have two generators here, and I have load here. Okay, so I am connecting these to power. This is my another power station here, and I have load here. Okay, it can be as many generators here. Okay, what I am saying, in case there is problem here or here or here, okay, there is fault here or here, what happens, the whole load that is connected to this system, it will get affected. In case it is not connected to this, there is no line, this is the transmission line. If these two stations are not connected, this station 1 and this station 2 are not connected with this transmission line, and if some problem dwells here, what will happen, this load will get cut off from the power supply. So what we do, when this power station is connected to this power station, in case there is some problem here or some maintenance or repair in this power station, what can we do, certain critical load, certain critical, this is the load. Okay, so it can be it consists of this domestic load, commercial load, industrial load, defense load, hospital load. Means this defense and hospital load, they are the critical loads. Okay, so these loads, these critical loads can be supplied from this power station using this transmission line. So we will say the reliability of the system is improved. So second point is reliability. Supply is improved. Okay, reliability of the supply is improved. Got it? Now the third important point is increased effective capacity of power system. Increased effective capacity of power system. Increased effective capacity of power system. Look what we say, we know that the we have, suppose we have different power stations or power systems, and each power system has its own load curve. Okay, and the load curve of the two power system, they are likely to differ, they will not be means same. Okay, so if the this difference in the load curve, so this will result, because of this difference in the load curve of the two power stations that are interconnected, what happens, this will reduce the maximum demand on the system. Okay, as on the interconnected system, as compared to the sum of the individual maximum demands of the two power stations separately. So what I am saying, I have two power stations, and the load curve of two power stations, it will never be same, it will always be different. Suppose let me show it here. Okay, I will show it with the help of a load curve, then only you will be able to understand. Suppose this is my one power station. Okay, so I will, let me draw the timings here. Timing here is, suppose I am saying this is 4 o'clock, this is 16 o'clock, this is 20 100 hours, this is 2400 hours. So it is like this. Let me draw the grid lines first. Okay, so this is 2, this is 4, this is 6, and this is 8. So I am saying from 0 to 4 hours, 400 hours, the load is 2 megawatt. From 400 hours to 1600 hours, the load is increased by 2 units, or no, it is 4 unit. And from 1600 hours to this to 2000 hours, the load is 6 megawatt, and then the load again reduces to 2 megawatt. From 1600 2000 to 2400 hours, the load is again reduced to 20 this 2 megawatt or 2 units. This is my power system 1. Okay, or power station 1. Similarly, I have another power station. It is like one power station is somewhere in South India, and another power station is somewhere in North India. Okay, suppose I will again draw the grid lines. So this is 4, this is 8, then I have 12, then I have 16, and then I have 16, then I have 20, and then I have 24. And let me draw the grid lines for this 2, 4, 6, 8. Okay, let's draw the grid lines, because drawing the grid lines makes easier. Okay, because you can easily get the intersection point of the time and this load. So this is my power station 2, and the load at the power station 2 is like this. From 0 hours to 800 hours it is 2 megawatt. From 8 to 1200 hours it is 4 megawatt. From 12 to 1600 hours the load is 6 megawatt. And from 1600 hours to 2400 hours the load is 4 megawatt. 1600 to 2400 the load is 4 megawatt. So this is my power station 2. So I am saying, what I was saying, the load curves of the two power stations are interconnected power stations. They are likely to differ. Like here, I have two power stations and load curves are here. Okay. So now I am saying these two power stations are interconnected, and I have to draw a common load curve of the two power stations, of the interconnected power stations. Okay. So if I will draw the common load curve of the two power stations, or if these two power stations are interconnected, what way I am saying that this result is the result is that the maximum demand on the system means when they two are interconnected, that the result is that the maximum demand on the system is much reduced as compared to the sum of the individual maximum demands on the two power stations. So if the maximum demand is reduced as compared to the sum of the two maximum demands, what will happen? The diversity factor of the system will improve. If the diversity factor will improve, what will we say? We are saying that this will increase the effective capacity of the whole system. So let me draw the common load curve of the power system comprising of these two power stations. So I will draw here 400 hours, then 800 hours, then 1200 hours, then 1600 hours, then 2000 hours, then 2400 hours. So I will draw here 2, 4, 6, 8, 10, 12. Let us draw the grid lines. Okay, so tell me what was the load, combined load on the two stations from 0 hours to 400 hours. So this is 4 here. So it was 2 here and 2 here. So 2 to 4, 4 mega. This is it will be 2 and 2 4. From 0 to 400 it is 4. Okay, 0 to 400 it is 4 megawatt. 2 here and 2 here 4. Now from 4 to 8, 4 to, suppose this is somewhere 8 here, 8, then I have here 12. 4 to 8 the load is here 4, and 4 to 8 the load is here 2. 4 plus 2 it is 6 megawatt. So 4 to 8 the load is 6 megawatt. Got it? You are getting it? How I am drawing a common load curve for the two power stations? Then let us see what is 8 to 12. From 8 to 12 the load here is 4, and 8 to 12 the load here is 4. So 4 4 8. So 8 to 12 the load is 8 megawatt. Now see what is the load for 8 to 12 hours from here. From means 12, for 12 to 16. From 12 to 16 the load here is 4. 12 to 16 the load here is 6. So 4 plus 6 10. 12 to 16 10. Now 16 to 20. 16 to 20 here 6. 16 to 20 here 4. 6 plus 4 10 again. From here to here. Now let us see from 20 to 24. 20 to 24 it is 2. 20 to 24 here is 4. So it is 6. So 6 is somewhere here. So the load curve will be like this. Okay. So this is the daily load curve. So what is the maximum demand of this load curve when I am interconnecting two power stations? The maximum demand is 10 here. So what is the sum of the individual maximum demands of the two stations? The maximum demand here is 6. The maximum demand here is 6. So sum of the individual maximum demand is 12, and the maximum demand of here it is 10. So that is what I am saying is, so this means interconnection of two power stations. The result is that the maximum demand on the system is much reduced as compared to the sum of the individual maximum demands. Okay, what is the sum of the individual maximum demands here? Sum of the individual maximum demand, it is 12 megawatt. And what is the maximum demand here? 10 megawatt. So this happened because of the reduction, because of the interconnection of these two power stations. So here I am saying the sum of the maximum demand is much lower as compared to the sum of the individual maximum demand. So what will happen? The diversity factor will improve. Okay. So and this here the capacity of the plant means we have to design for this load, we have to design the plant for 6 megawatt, and here we have to design again for 6 megawatt for 12 megawatt. But if we are interconnecting, we are saying the maximum demand is 10 megawatt. Okay, so these are the advantages of the increase effective capacity of the power system, because it will increase the capacity of the power system. Okay, next important point is economical operation. Look, what do you mean by economical operation? Suppose we have two means power stations. One is hydro and another is thermal. Okay. So you know that this in case of a this hydrothermal power plant, it is economical because we don't have any running cost. Means we don't means the cost of fuel is zero. Okay, though there are maintenance costs and other costs, but the cost of the fuel, it is zero. So what happens when water is available in sufficient quantity? When water is available in sufficient quantity, hydro plant is used. Okay, if we know that we have a sufficient quantity of water is available, that we can run the plant throughout the year, in that case we will use hydrothermal power plant as the base load power plant, hydro power plant as the base load power plant, and thermal power plant as the peak load power plant, if the sufficient quantity of water is available throughout the year. But if not, then what we will do, we can use thermal power plant as the base load and hydro as the peak load. Okay. So use of this making use of this hydropower plant and thermal power plant, it will make the system operation. What if means suppose I have a my load is 900 megawatts. So what I will do, I have 500 units of two means power station. One is 500 thermal and 500 hydro. So 500 plus 500 is 1000 megawatt, and my load is suppose 950 megawatt. Got it? So if water means so I will interconnect these two power systems. So the cost of, obviously I'm saving some fuel cost while putting 450 load on this hydropower plant. Got it? So this operation makes means this interconnection of the power station, it makes the operation economical. So also economy is achieved by sharing the load demands among the interconnected power stations. Okay, what do you mean by sharing the load demands among the interconnected power stations? So I will say that economy is achieved by sharing the load demand among the interconnected power stations in such a manner that the most efficient plant runs continuously. Means most efficient plant, it runs continuously runs continuously, okay, throughout the year at higher load factor. Okay, and less efficient plant, it operates for peak hours only. It operates for peak load only. Okay, what I am saying, I have suppose three plants here, one plant here, one plant here, and one plant here, and all the plants are interconnected with the help of a transmission line. Okay, I have three plants. Okay, I am saying economical operation, how it is achieved. Number one means what I will do, I will means I am making use of hydro and thermal. Hydro is cheaper, so that is why I am saying economical operation is achieved. And I am saying if hydro is water is available in sufficient quantity, then hydro plant is used for base load and thermal is used for peak load. But if the water quantity is not available in sufficient, if the water is available is insufficient, then thermal is used as base and hydro is used as peak. Another way I am saying economy is also achieved by sharing load between the interconnected power stations. Okay, so I have load here, I have load here, I have load here. Okay, so what happened, how economy is achieved by sharing the load between the interconnected power system. I am saying, suppose I am saying that this is the most efficient, one is the most efficient, two is less efficient, and three is the least efficient. Okay, so what I will try to do, I will try to means, I will say this one plant one, it will operate all the time at higher load factor. Okay, means suppose here I am saying it has a capacity of means 1000 megawatt, it has a capacity of suppose 500 megawatt, and this has a capacity of 500 megawatt. Okay, the load here, suppose I am saying 400 megawatt, so it is 2000, so 400 megawatt. Here the load is 450 megawatt, and the here load is 950 megawatt. Okay, so I am saying, though this is least efficient, so total load here it is 4 plus 450, 950 plus 950 means 1900 megawatt, and the generation is 2000 megawatt. So what I will do here, though the load on this power station it is 950 megawatt, but I will operate it at 1000 megawatt at its full capacity. Okay, so this is the most efficient. So 50 megawatt which it is extra generating, it will supply to these two plants, plant here and plant here. Okay, because we know that generation from these two plants, it will be costlier as compared to the generation from this plant. So the extra 50 megawatt which is this is plant is generating, it will supply to either this or this. Since this is the least efficient, it will supply 50 megawatt, it should supply 50 megawatt to this. Okay, so because the plant which is less efficient, we will it is means normal tendency to put less load on that plant. Okay, so this is the economical operation. So next is use of older plants. Use of older plants. So I will say that interconnection makes it possible to employ the older and less efficient plant to carry peak loads. Means to carry peak loads for short duration. Look, we can have means na old power plant, maybe the capacity of the power plant is very high. Okay, but it is less efficient. So if it is less efficient, it is means useless, means there is no sense to use that older and less efficient power plant for a longer period of time. Okay, though it has the capacity, it can supply, but the efficiency is very low. So what we do, if this plant, older plant, is interconnected to a grid, in case we have a peak load, of suppose 2 hours or 3 hours a day. For 2 or 3 hours a day, we can use this older power plant. Okay, so this interconnection makes it possible. Okay, so sixth is exchange of peak load. So what do you mean by exchange? By exchange of peak load, we mean that peak load of the power stations can be exchanged. Okay, peak loads of the power station can be exchanged. I'm saying if load curve of power station indicates a peak demand exceeding its rated capacity of the power station. So what will happen then? The excess load can be supplied by other power station interconnected to it. Okay, how can I explain it? Okay, I can explain it here. Suppose I am saying that I have a plant here. I will take a case of these two cases. Suppose I am saying that this means a plant, this power station, it has a maximum capacity of 6 megawatt. This power station, it also has a maximum capacity of 6 megawatt. Got it? So when is the peak load arising here? Means from 1600 to 2000 hours, it is operating at its full capacity. Okay, because the peak load is 6 megawatt. However, this plant, it is operating at its maximum capacity from 1200 hours to 1600 hours, that is 6 megawatt. Both have the same capacity. Suppose I am saying it has a maximum capacity of 6 megawatt, and all of a sudden the load here increases somewhere, means from 16 to 2000 megawatt, the load here increases beyond, it goes beyond 6 megawatt. Suppose it goes slightly up, it goes here to suppose 7 megawatt. Okay, it has a maximum capacity of 6 megawatt, but the load increases to 7 megawatt. What will happen? From 1600 to 2000 hours. Okay, so the load has increased, the load has gone beyond its maximum capacity. What will happen? Since this power station is connected to this power station. Okay, and you can see that from 1600 hours to 200 hours, what is the load here? It is 4 megawatt, but what is the maximum capacity? 600 megawatt. So this load, this power station, it has some 2 megawatt of capacity here, reserve capacity. So it can supply the 1 megawatt of power to this power station from 1600 hours to 2000 hours. It cannot supply it in between 1200 to 1600, but beyond this time, 1200 to 1600, before 1200 hours and after 1600 hours, it can supply power to this power plant, this power station 1. Okay, so the 1 megawatt extra power, that load that means is there on this power station, so that can be supplied by this power station. Okay, this is called exchange of peak loads. Means one power plant, it can supply the peak load of the other power plant. Okay, provided it is not provided that plant itself is not operating at its peak load. Okay, got it. So this is I think which point this was, 6th point. Then the 7th point was reduces capital cost. So with interconnected system, that is generator of large sizes can be employed. Okay, so means I know that I have interconnected power system, so I can use a generator, bigger generators. Okay, so and this means bigger. If you are using, suppose you have 100 megawatt, you have 150 megawatt unit. Okay, so if you will use 20 units or 10 units of 15 megawatt, so obviously these 10 units of 50, each of 15 megawatt, it will means the cost of these 10 units will be more as compared to a single unit of 150 megawatt, because it will 10 units, they will consume more material. Okay, more material is used, more cost will increase. Moreover, if you are using 10 machines, so you need more floor area. Okay, if you are using one machine, you need less floor area, you need more maintenance, you need less maintenance. Okay, so but the reliability here is more, the reliability here is less. So but if you are using a single unit of bigger capacity as compared to a multiple units of smaller capacity, the cost of the bigger unit, it will be less as compared to the cost of the and smaller units. So I think that is it. I cannot means include the another topic in this unit, because already I have made one lecture of video for 20 minutes, and the second video, it has also exceeded 27 minutes. So I think it is sufficient for today's lecture. So in the next lecture, I will continue another topic. Thank you very much.